this unit of matter, most of the times we've talked about how to change the state of matter, how to go from a solid to a liquid to a gas. And when we've done that, we've always involved temperature. We've talked about if we heat a solid, we can get the particles to break free from those fixed positions, move fast enough, and become a liquid. And then we could keep heating it and it would go to a gas. Or we could remove heat. We could allow the heat to go the other direction and get it to go from a liquid to a solid and freeze. But we also have another situation that we could use to change our states of matter, and that's if we involve pressure. So this is what's called a phase diagram. And so your phase diagram is going to show you the states of matter and at what temperature and what pressure they would exist. So temperature's here on your x-axis, and the least amount of temperature, the lowest kinetic energy or average kinetic energy, would be a solid. Because think about it, solids are going to have your lower kinetic energy. They're just vibrating in position. So clear over here on your x-axis is where you'll find your solid. So if we look, we notice up here, there's a little s. This whole area on this side of the diagram is a solid. Anything found in this area is a solid. As we go over, in this little funnel part of our diagram, we find what's called the liquid. Okay? And then to the right, where you have the highest kinetic energy, the highest average kinetic energy, it makes sense that you would have a gas. And so over here to the right of this, you can see that everything from here on over would be the vapor or the gaseous state of the substance. Well, this phase diagram happens to be with carbon dioxide. And carbon dioxide is something that you breathe out. It's a waste product. You get it out of your body. You've seen it in terms of maybe carbon dioxide fire extinguishers before, but you've also seen it with dry ice, and you'll see more of the dry ice on Friday. However, dry ice is the solid form of carbon dioxide. So let's look. Our normal atmospheric conditions is about 1 atm, and the side here tells us 1 atm for the y-axis. So at 1 atm, solid dry ice has to be about negative 79 degrees Celsius. It's pretty cold, okay? If we start going to room temp, around 20 something here, notice we are definitely in a gaseous state. But at 1 atm, notice that your dry ice goes directly from a solid into a gas without ever being a liquid. There was no time that we crossed in the liquid at 1 atm. So this is why dry ice sublimes. So when we put the dry ice out on my desk or anything like that, you'll notice there's no liquid residue, it just sublimes. It goes to a gas and it's gone. It's not going to melt in front of you. But if you look at this phase diagram, we notice we can do a couple things. If we change the temperature and we increase the pressure, we can get it to a liquid. So in tomorrow's lab, you're going to be doing that. You're going to be increasing the pressure because the temperature change is going to happen on its own because it's going to be in our classroom, and our classroom is going to be a lot warmer than negative 56.6 degrees. Now, if we increase the pressure, we can get the dry ice to go from a solid to a liquid to a gas. So we can get it to melt and we can get it to boil. But we can also do it right here at what's called the triple point. The triple point is the pressure and temperature at which all three states of matter will exist at the same time. You'll see it as a solid, you'll see it melting, and you will see it boiling. And that's what we're going to do with the carbon dioxide. So we look at this phase diagram. Temperature has to be about negative 56.6 degrees Celsius. Like I said, easy to do that in my classroom. Pressure, we got to ramp the pressure up to 5.11 atms. So here's what you're going to do. You're going to be given a pipette tomorrow. Okay? You know I'm not able to draw. Here's your thin pipette. Okay. In the pipette, we're going to put some solid carbon dioxide, some dry ice, right here. Okay? You're going to then take it. You're going to take your needle nose pliers. You're going to fold this over a couple times and then seal it with the pliers. Now, I'm not going to attempt to draw pliers, so that's what you get. You're going to seal this, and then you're going to put it into a plastic cup of water. We're going to watch what happens inside here. We're going to look at it, and we're going to see if we can find triple point. If we can see when we have a solid, a liquid, and a gas all at the same time. Okay? You want to keep it down in your water. The cups are clear, so you're going to be able to see through it. Every once in a while, you can take it out and look at it. But you kind of want to keep it down in the water as much as possible. This is going to take a lot of strength on your part because you have to get it up to 5 atms, 5 times the normal amount of pressure, so you got to really squeeze to make sure none of this gas is escaping. So this is what we're going to do tomorrow with our experiment. Remember, you're looking for the triple point, the solid, liquid, gas at the same time, and this is what we're expecting to see tomorrow. We're expecting to see that if we get it to about 5 atms, 5 times the normal pressure, we're going to be able to see all 3 of them.